All right, welcome to this next part of the G-table discussion we were having. Suppose these are the 5 data points you have: 46, 54, 42, 46, and 32. So the mean here is 44, and the standard deviation mu, sigma, is 8. Okay, you have to trust me on this. You can go ahead and do the calculation. You should get the same value. So as I said, I'm assuming this is a normal distribution. So suppose this comes from a normal distribution. Right? There are a lot of data sets. We saw this, and this normal distribution we can represent as mean, or I could write x bar or mu, similar idea, is 44, and the standard deviation is 8. Right? But I want to find out any value. I could really find now the mean is 44, so less than 44 is on the left side, more than 44 is on this side. I want to find out, let me take a nice number here. Suppose I want to find out this the first value, 46. I want to, 46 would be here, isn't it? So left of 46, I want to find out what percentage of the value lie left of 46 and what percentage of the value lie right of 46. Okay? This is what I want to find out. Let me change the color. As I said, we don't have a table for mean of 44 and a standard deviation of 8. I mean, that will take way too many tables. The way we have defined G is, suppose there is another hypothetical normal distribution, call it standard normal. The property of standard normal is it has a mean of 0 and a standard deviation of 1. All I gotta do is I gotta find out what is the equivalent of this 46 in this value. Well, the first thing I obviously know, right, let me bring it. What is the equivalent of this 46 in this value? I want to find that. And that is what we call Z. The equivalent of any value from any normal distribution in the standard normal, that is what G is. So we want to find the equivalent of this 46 in this standard normal. After that, we're done. So let's call this the Z-score. Right? This Z is what the Z-score is. The formula is, all you need to know is you want to find the G of 46 minus the mean from where it came from, 44, divided by the standard deviation where it came from, 8. So it's 2 divided by 8 equals to 0.25. Let me repeat this again. You want to find the G of any value. If you want to find the G of, say, 42, you do 42 because you wanted to find the Z of 42, the equivalent of Z in here, minus the mean of where it came from. It came from a mean of 44, divided by the standard deviation of where it came from, that is 8. So minus 2 divided by 8. That is minus 0.25. Now a sanity check would be, if you are taking a value less than the mean, in this case 42 is less than 44, your Z should come out to be negative, because the only way you can be left of 0 is if you are negative. Right? If you are using a value higher than your mean from the distribution it came from, your G should be positive. That's why we have 0.25. Now, a small addition, the way G table is described. So suppose now you found the G value. You found your Z value equals to 0.25. Z table is described this way. Cumulative to the left. I mean, you could have defined it any way. Somebody decided to define it in terms of cumulative to the left. So you find the value 0.25 and it will give you the percentage or the fraction that is left of 0.25. Right? If you find what percentage of the value is left of 0.25. If the question is asking right, obviously you would have to do 1 minus whatever you get. Right? You have to get whatever this value is. The percentage equivalent of Z, you look at the table and you subtract it from there, you get the value right to it. Okay? We'll do this in Excel. and you should be able to follow, and you probably know most of it. I just gave you the insight behind it. If not, we'll show you me working with the how to find a G table. I'll have to upload a PDF, and I'll show you how to read through the G table value. Okay, all right.